Using a flash cartridge on your Commodore 64 is super convenient. You can load it up with all the software you love and launch games and apps using clever interfaces. The one compromise, however, is that you miss out on the physical aspect of loading games. But not anymore. Now you can launch C64 games using NFC cards. This is the TeensyROM, and today we're going to make one and take a look at how it works. If you've been around the channel for a while, then you know how much I love covering different emulation technologies. But at the end of the day, there's nothing quite like experiencing the real hardware. So I still enjoy breaking out my Commodore 64 every now and then to spend some time with. Flash carts for the C64 aren't anything new. They've been around for quite some time, and there are a couple of different options to choose from. Personally, I've been using a Kung Fu flash cartridge for the past few years, and it's worked out pretty well. But sometimes, it can be a bit overwhelming to scroll through a game library, and decision paralysis kicks in. That's one of the reasons why I'm still a fan of physical media, and why I covered the Tap2 NFC loading project for the Mister a few months ago. But there's no reason why NFC game loading has to be limited to modern systems. This is the TeensyROM. It's a flash cart for the C64, which does more than just let you load cartridge or disk images. At the heart of the TeensyROM is a Teensy 4.1 microcontroller. This is a 600 MHz ARM Cortex-M7, which the TeensyROM overclocks to 816 MHz. It's one of the more capable microcontrollers on the market, with a megabyte of RAM, 55 I/O pins, multiple serial ports, a USB host controller, real-time clock, Ethernet controller, microSD card slot, and much more. And because it has all these features, the price is a bit higher than some of the other microcontrollers on the market. At the time I'm recording this, you can pick up a Teensy 4.1 from DigiKey for around $32, whereas a less feature-rich MCU, such as the Raspberry Pi Pico 2, goes for $10. But since it's such a capable microcontroller, you can squeeze a lot of functionality out of it, and the TeensyROM is a testament to this. Not only does it load C64 ROM images with its easy-to-navigate interface, but it can do so from the built-in microSD card, a USB thumb drive, or its internal flash chip. And the TeensyROM even puts your Commodore 64 on the internet. Just plug it into an Ethernet connection, and you can connect to retro bulletin board systems, or even browse the web using the TeensyROM's integrated web browser. And this is all great, but the main thing that I'm interested in is its NFC support. So let's build one and see how it works. In order to build a TeensyROM, you're going to need to pick up a PCB. And there's no better place to order your TeensyROM PCB from than my friends over at PCBWay. The ordering process is simple and hassle-free. You just need to grab the Gerber zip from the TeensyROM GitHub project and use PCBWay's Quick Order PCB tool. You can just give it the entire file and then select your options before adding it to your cart. Now, if you're just making a TeensyROM for yourself and plan on keeping it inserted into your C64 all the time, then you'll be fine going with the default board options. And in that case, $5 will get you 5 boards, so you'll even have some extras to give to your friends. On the other hand, if you're going to be inserting and reinserting your TeensyROM a lot, then you really should be using gold plating on the edge connector. And for that, you'll just need to select the Immersion Gold Finish option. It's more expensive, but it's worth having the durability and electrical reliability that comes with gold. And while you're at it, you can also have PCBWay 3D print the cartridge shell. And they'll even post-process the print with a nice finish. So if you're going to follow along with this video and build your own TeensyROM, do me a favor and grab your boards from PCBWay. By supporting PCBWay, you're also supporting me, so thank you for that. And I also want to give a very special thanks to the team over at PCBWay for sponsoring this video and for providing me with parts to make cool things. In addition to the Teensy 4.1 and the PCB, you're also going to need a few other parts. First, you'll want to pick up some passive surface mount components. Most of these will be in an 0805 package. 0805s are still tiny components, but they're not too difficult to work with when using tweezers and a soldering iron. You'll need 3 resistors. One of them is a 1 kiloohm, and the other 2 are 10 kiloohm. And along with those, you'll need 8 ceramic capacitors. 6 of them will be 0.1 microfarad, but the remaining 2 will be 22 microfarad. And you'll want to purchase those in a 1210 package size. And of course, we'll need a few chips. First, there's a 7400 series LVC07. This is an open drain buffer chip that's used between a few of the signals on the cartridge port and the TeensyROM. Aside from that, there's also 4 LVC245s, which are all 8-bit bus transceivers. These are used on the communication lines between the Teensy and the C64. We'll also need some connectors. 2 strips of 24-pin single-row male headers connect the Teensy to the PCB. A 5-pin single-row header connects the Teensy's USB host pins, and a 3-pin double-row header is used for the Teensy's Ethernet connection. It's important to note that the double-row header has a 2mm pitch instead of the standard 2.54mm. Alongside those, we'll need a few miscellaneous parts, such as a 3mm LED, a 6mm tact switch, an RJ45 connector, and a female USB-A port. And though it's not necessary, it might be a good idea to pick up a small heatsink for the Teensy as well. We're going to start the build process by first installing the firmware onto the Teensy. Now, this initial load needs to happen on the computer before you solder the Teensy onto the TeensyROM PCB. But subsequent updates are just a matter of dropping the update file on the SD card and then running the file from the TeensyROM inside your Commodore 64. First, you'll need to download a program called the Teensy Loader, which you can get from the PJRC website. I've included the download link in this video's description. Once you've downloaded that, you'll need to grab the latest firmware hex file from the TeensyROM's GitHub repository. Then launch the Teensy Loader, click on the document icon, and select the hex file you downloaded. Next, plug your Teensy into your USB port. If you've never used this Teensy before, it'll run the standard microcontroller Hello World program and blink the LED. You'll then need to press the button on the Teensy in order to run the built-in bootloader program. After that, you can just click the upload button in the Teensy Loader, and the firmware will be sent to your Teensy. You can now go ahead and unplug your Teensy from your computer, and we'll need to make a small modification. If you turn it over, you'll see 2 rectangular pads next to the USB port. You'll need to use a hobby knife to sever the thin trace that's connecting these 2 pads together. What you're doing is separating the USB voltage pin from the board's 5-volt supply line, and this lets you use an external power source. Now we can go ahead and start soldering components onto our PCB. As usual with these types of builds, we want to start with the lowest profile components first. So we'll start with our surface mount resistors. The pad labeled R2 is first, and it gets the 1 kiloohm resistor. Now, the technique to use is to first put down a little solder on just one of the pads. Then heat up the solder blob with your iron while bringing the component into the melted solder with tweezers in your other hand. Move your iron away while keeping the tweezers still for a moment, and when the solder cools down, you can then remove your tweezers and place some solder on the other pad. After you get R2 in place, you'll want to place your 10 kiloohm resistors at R1 and R3. Then you'll want to grab your 0.1 microfarad capacitors and place those in the spots labeled C6, C7, and C8. Then flip the board over and solder the remaining 3 onto C3, C4, and C5. Next, take your 22 microfarad capacitors, which are the bigger ones, and solder those in the spots labeled C1 and C2. Okay, next we'll put on the surface mount chips. You want to make sure that you put the chip on in the right orientation. The dot on the board indicates pin 1, which is going to be the pin directly to the left of the semicircular divot on this side of the chip. The silkscreen also indicates where this divot is, so that's another indicator of the direction that the chip should go in. We'll start with U6 here, which is the LVC07. Start by placing a little solder on one of the corner pads. We'll use the same technique that we used for the smaller parts, so go ahead and bring the leg of the chip into the melted solder. Before moving away your soldering iron though, make sure all the legs are lined up correctly with the other pads. Then if everything looks like it's straight, then you can go ahead and solder the others into place. Next, we'll do the remaining 2 chips on the top side, which are both LVC245s. And we'll flip the board over and place down the remaining 2 LVC245s in the spots labeled U2 and U3. Next, we'll solder in the tack switch. The button sits on the top of the board, and the legs are soldered in from underneath. We'll then solder in the LED, being careful to observe the correct polarity, of course. And then the USB port next to it. Alright, now we have some male headers to put down, which all get seated with the short side of the pins on top of the board. I'll start with this single row 5-pin header and place solder on only one of the pins. You'll want to ensure the header's straight and flush with the board before soldering the remaining pins. Otherwise, the Teensy won't fit properly. And we'll use the same technique to solder on the 2 24-pin headers. Now we need to turn our attention to the Teensy itself and solder on the 2x3 male header block for the Ethernet controller. The short side of the pins get inserted from underneath the Teensy, and you'll solder them in place on the top side of the board. Okay, with that done, we can now seat the Teensy into the PCB. Press it all the way down, and then solder the pins to the Teensy. After all those pins are soldered, flip the board over and solder the 6 pins for the Ethernet connection to the underside of the cartridge PCB. And the final component is the RJ45 Ethernet jack. That should just fit right in on the top side, and then we can solder it underneath. Everything's ready to go, but I really don't want to keep the board exposed to the elements, so I'm going to place it into this resin-printed enclosure that I got from PCBWay. The STL files, which you can provide directly to PCBWay, are in the TeensyROM GitHub. The board fits right in, and it's held together with a single 15mm M2.5 screw. There's also an alternative version I found on Printables, which is a little less bulky. This case is called the TeensyROM Exposed. It's mostly the size of a standard C64 cartridge, but it has cutouts for the Ethernet port and the heatsink to stick out of the shell. Okay, I think we're ready to try it out. We'll insert a micro SD card with some software on it and plug it into my Commodore 64. And thankfully, it powered right up, and we get the TeensyROM menu screen with some SID music playing in the background. Very cool. You'll notice that the screen here says the source is Teensy Memory, and we see a list of folders. This is all software that came preloaded into the TeensyROM firmware, and it resides on the Teensy's internal flash memory. If we press F3, the TeensyROM switches over to the micro SD card, where I've copied over the OneLoad 64 collection. This is a curated selection of games in CRT format, which all load very quickly. Let's try out an all-time classic, Impossible Mission. And you can see that the game loaded right away when I pressed return.
Another visitor. Stay a while. Stay forever.
Now to get back to the menu, you just press the button on the cartridge. It takes a couple of seconds and then brings you right back to the last place you were in the menu screen. Alright, game loading seems to work as expected, but all flashcards do that. So let's move on to some of the more interesting features. And for that, we'll plug in an Ethernet cable. Let's navigate back to the TeensyROM's internal memory by pressing F1, and we'll go into the Utilities folder and launch CCGMS. This is a popular terminal program for the C64, and as you can see, the TeensyROM bundles it into the firmware. We'll need to run a few commands here. First, the AT command will make sure we're ready to go. Then we'll run ATC, and that should tell us our connection status and shows our IP address. And then we can use the ATDT command to connect to a BBS. For this, I'll use one of my favorites, Retro Campus BBS, which is run by a friend of the channel, Francesco out of Milan. Let's see what's going on with the Vintage Computer Federation. Ah, that's right, VCF East is coming up in April this year. I really enjoyed going last year, but unfortunately it falls on the same weekend as Midwest Gaming Classic, so I won't be able to make it. But if you happen to be at Midwest Gaming Classic, be sure to come by and say hi. I'll be helping Ben with the Game Badge Workshop again this year, and I believe there's still seats available. So consider signing up for that, and we'll teach you how to build your very own game badge. If BBSs aren't your thing, you can also use CCGMS to browse the World Wide Web directly from your Commodore 64. Just run the AT-browse command to put the terminal into web browser mode. From here, you can browse to a URL directly, or you can search through FrogFind by typing S and entering the search term. You can also store and access bookmarks, and even download files directly from the internet onto your microSD card. Let's now go back to the menu and try out a feature that I'm really excited about. And for that, we're going to need this device. It looks like a miniature 1541 disk drive, but it's actually a USB NFC reader designed by Ninja 3DP. I've put a link to the 3D model below in case you want to make one of your own. This plugs into the USB port on the TeensyROM. And then we'll need to go into the settings menu by pressing F8. We'll toggle option F to enable NFC support, and reboot the TeensyROM. Before we can use it, we need to program a tag. So we'll browse to a game, press the left arrow button, and that will take us to a different screen for writing the NFC tag. Now we can insert the NFC card and press a key to continue. And a second later, we have the card loaded up with the data to run the game. So now if we reinsert the card into the reader, Ghostbusters launches instantly.
Ghostbusters!
Overall, I have to say that the TeensyROM is definitely one of the neatest flash carts I've seen. In fact, I think I'm going to be putting my Kung Fu flash cartridge into retirement and using the TeensyROM from this point on. If you want to make one of these, then head over to PCBWay and get some boards made. The Gerber files are in the TeensyROM GitHub repository, which I've linked in this video's description. Alright, that's it for today, so I'll see you next time. But as always, until then, go make something cool.